Dear students, the last class we were talking about a problem of the first model, okay, that is a replacement of item that deteriorate over time, that is whose maintenance cost increases with time, ignoring the changes in the value of money during the period. So in that problem we talked only about one resale value or one scrap value, right? So in this session we will discuss about we will deal with another one problem of the same model, that is the first model with different resale values, okay, not the single resale value, with different resale value. We are talking about an example of the first model itself, that is replacement of item that deteriorate over time, whose maintenance cost increases with time, and again we are ignoring the changes in the value of money. Okay, this is the second example of the first model. Okay, now consider this particular example. The purchase price of a machine is rupees 9,000 and its installation charge amount to rupees 1,000. So the maintenance cost and resale value per year of a machine is given below. So you have 8 years, okay, given 8 years, then maintenance cost is given and different resale value for different year. So here you can see for the first year the maintenance cost is 1,000 and its resale value is 6,000. Second year maintenance cost is 1,500, resale value is 3,500. Third year maintenance cost is 2,000, resale value is 1,600. Then fourth year 2,500, 800, 3,700. Then for sixth year 4,000 and 500. Seventh year 5,100, 400. Eighth year 7,000 and 400. So from this question we can understand that as the year passes on or as the time passes on, the maintenance cost is increasing wherein the resale value is decreasing. Okay, so here different resale values are given for each year. So how we will do the problem? That is a question. Then here we are asked to find when should the machine be replaced. That is, we have to find the optimum replacement time or optimum replacement year. Okay, so similarly, just like how we did that previous problem, you will have to draw a table. So this is your table. Okay, in this you have 7 columns wherein you have years of service, resale value, then the depreciation cost, annual cost, cumulative maintenance cost, total cost, and average annual cost. It is all the same columns, right? Okay, now I have filled in 3 columns, that is year of service 1 till 8, you have 8 years of service. Then resale value is already given in the question, right? Here in this question you are given the resale value, that is 6,000 for the first, 6,000, 3,500, 1,600, 800, 700, 500, 400 and 400. Okay, and again the annual maintenance cost is also given in the question, right? I have filled in all the annual maintenance cost for each year. Now the third column, that is a depreciation cost. How we will find depreciation cost? Depreciation cost is equal to purchase price minus resale value. Now what is the purchase price given in the question? In the question it is given that the purchase price of a machine is rupees 9,000 and its installation charge amount to rupees 1,000. This is actually to confuse the students. Okay, so normally what students will consider is purchase price will be considered as 9,000, but that is not right. This installation charge also counts in purchase price. So the total purchase price will be 9,000 plus 1,000, that is total 10,000. So whenever an installation charge is given, you need to remember that has to be added with the purchase price. So total purchase price will be 10,000 rupees. So 10,000 minus the resale value. So for resale value for each is different. So here first one is 10,000 minus 6,000, that is equal to 4,000. The first one is 4,000. Again 10,000 minus 3,500, you will get 6,500. 10,000 minus 1,600 is 8,400. 10,000 minus 800 is 9,200. 10,000 minus 700 is 9,300. 10,000 minus 500 is 9,500. 10,000 minus 400, you will get 9,600. Here also 9,600, right? So all these 4 columns are done. Next is the 5th column, that is cumulative maintenance cost. I have already written down the maintenance cost. Now cumulative maintenance cost is, the first one will be 1,000. 1,000 plus 1,500 will be 2,500. 2,500 plus 2,000 is 4,500. 4,500 plus 2,500, 7,000. Similarly, you have to keep adding with this value. So 7,000 plus 3,000 will be 10,000 then 14,000 and 19,100, and finally 19,100 plus 7,000, you get 26,100. Okay, then the next one is total cost. So total cost is equal to third column plus fifth column, that is depreciation cost plus total maintenance, cumulative maintenance cost plus 1,000. 4,000 plus 1,000, you will get 5,000. Then here 2,500 plus 6,500, you will get 9,000. Then 12,900, then 16,200, 19,300. How 19,300? 10,000 plus 9,300. Then 14,000 plus 9,500, you will get 23,500, 28,700, and finally 35,100. Then the next is average annual cost, that is the sixth column. This column divided by the first column. So 500 divided by 1, you get 500. Then 9,000 divided by 2, you get 4,500. Then similarly 4,300, 4,050, then 3,860, 3,970, 4,100, and finally 4,388. Now all the columns are done. So out of this, which is the minimum value? That is what we have to find out. So this is 5,000. Okay, total cost is not 500, 5,000. So we have to find out the minimum value. Now look at the average annual cost. 5,000, 4,500, 4,300, 4,050, 3,860, 3,970, 4,100, 4,388. So out of this, 3,860 is the minimum average annual cost, and it is corresponding to the 5th year, right? So our selected year is 5th year. Now which is the next year? The next year is 6th year. So you have to look for the annual maintenance cost of the 6th year, that is 4,000 rupees. Now 4,000 is greater than 3,860, right? So in that case, we can say that the replacement policy is satisfied. What is our replacement policy? Our replacement policy says that if the running and maintenance cost of the machine for the next year is more than the average annual cost of the selected year, then replace the item at the end of the selected year. Just like how we did in the previous problem, here you have to check for the next year, that is the 6th year, what is the annual maintenance cost, that is 4,000 rupees. So definitely 4,000 is greater than 3,860. So you can write, since 4,000 is greater than 3,860, we can say that we can select 5th year as the optimum year for replacement. Okay, so the optimum replacement period is the end of 5th year, That is the optimum replacement period. Okay, I hope this problem is clear to you. These are the two examples which comes under the first model, that is you are replacing an item whose maintenance cost is increasing with time, but we are not considering the value of money. That is the first model. So the first model is done. So the next model is replacement of item that deteriorate with time, that is whose maintenance cost increases with time, and change in value of money is also considered with the passage of time. This is the second model. We will deal with the second model in the next video. Okay, thank you students.